Dear learners, welcome to video lectures for engineering students. In this video, we will be looking into the energy aspect in engineering mechanics, a topic called energy. What do you mean by energy? So generally, energy is the capacity to do work. Okay, the capacity of doing work is known as energy. We know what is work. Say, we can define work is said to be done when the point of application of a force moves in the direction or the component of the direction of the direction of the component of the force. So that is work done. Now energy means the capacity to do work. That is called as energy. You might have heard of energy, many different type of energy. Say the most common and familiar one is electrical energy. Then there can be chemical energy, there can be magnetic energy, there can be elastic energy, say in case of springs, etc. Then nuclear energy is there, gravitational energy is there, thermal heat, then potential energy is there, kinetic energy is there. All these are different type of energies existing in the universe. So in engineering mechanics, we are concerned only with two types of energies. That is, the first one is potential energy. First one is potential energy, and the second one is kinetic energy. So potential energy and kinetic energy are two different type of energies, which are the main concerns in engineering mechanics. Okay, so let us see what is potential energy. So potential energy is the energy possessed by a body due to its position above a reference plane line, or it is also called as a datum. Potential energy is also known as position energy or datum energy. Okay, so what is potential energy? It is the energy by virtue of position of a body with respect to any given reference or datum. So this is very important, with respect to any given reference or datum. That is called as potential energy. Okay, so if a body is resting or which is held at a position h meters, at a height of h meters from the ground, h meters, and if its mass is m, then the potential energy Pe will be equal to mgh. It will be equal to potential energy equal to mgh, where h is the height above the datum. This is the datum or the reference line. So normally if we say a body is kept at a height of 10 meters, means normally the datum will be the ground level. So if h is the height above which the body of mass m is kept above the ground level, is if it is h meters, then the total potential energy will be equal to mg into h. So instead of m, if w, the weight is given, it will be w into h. Potential energy is equal to w into h. So that will be potential energy. Then the next kind of type of energy, which is mainly dealt with in engineering mechanics, it is kinetic energy. Kinetic energy. From the term kinetic itself, we can easily understand that it is something related to motion, movement of a body. So the energy possessed by a body by virtue of its velocity or its motion is known as kinetic energy, and it is represented by Ke. Okay, so the energy possessed by a body by virtue of its velocity or its motion is known as kinetic energy. So you can see the expression, how the expression, say equation for kinetic energy. If m is the mass and v is the velocity, then kinetic energy equal to half mv square. Kinetic energy is equal to half mv square. That is the equation for kinetic energy. As we have seen, the potential energy for a body kept at h meters above the datum, it is mgh. Like that, for kinetic energy, the equation is half mv square. You might have studied this in your +1, +2 level. So, how can we get this equation? Just look at this derivation. So, work done is equal to force into distance, that we know, F into S. So, force is mass into acceleration, that is F is equal to m into A. Substitute the value of F in equation 1, that is F into S. F is equal to m into A into S. Will give you m into A into S. So, we know the equation for displacement, it is, we have an equation v square equal to u square plus 2a into s, where v is the final velocity, u is the initial velocity, a is the constant acceleration, and s is the distance, displacement. So, from this equation, we can get s. So, it is, so from this equation, we will get v square minus u square equal to 2as. V square minus u square is equal to 2as, or v square minus 0 square equal to 2as, where a body is starting from rest. Its motion starts from rest. That means v square is equal to 2a into s. So a into s is equal to v square by 2, or substituting the value of a into s, work done is equal to mv square by 2. Work done is equal to mv square by 2. Then work done on a body is equal to kinetic energy. That principle is called principle of work and energy, or work energy principle. Work energy principle. So with this principle, kinetic energy is equal to, or work done is equal to change in kinetic energy. Change in kinetic energy. But in our case, the body started from rest, and hence the initial velocity is 0. So change in kinetic energy is half mv square. Half mv square. So the work done is equal to half mv square. And the kinetic energy of that body, which is starting from rest and moving with v meter per second square after t seconds of motion, then the kinetic energy of that body at that position is half mv square. Okay. Let us see what is principle of work energy. That is that we have already seen. Work done is equal to change in kinetic energy. Suppose a body is moving with a velocity of u meter per second, and after some time t seconds, the velocity is v. Then the kinetic energy, change in kinetic energy of the body will be equal to the work done on the body. Okay. So we know that F is equal to ma from Newton's second law of motion. F is equal to ma, that is the net force acting on a body is equal to mass into acceleration, where F is the resultant force, m is the mass, and A is the acceleration in the resultant in the direction of the resultant force. We know another equation, that is acceleration A is equal to v into dv by ds. V is equal to dv by ds. From where we got this equation, that is dv by dt is equal to, this can be expanded in using chain rule of differentiation. Okay, we will get it as, that is ds by dt into d dV by ds. ds by dt into dV by ds. Because V is a function of S and S is a function of t. V is a function of S and S is a function of t. Therefore, we can write this equation dV by dt is equal to ds by dt into dV by ds. But we know dV by ds by dt is that is rate of change of displacement with respect to time. It is v. So v into dV by ds. That is equal to acceleration a, because dV by dt is acceleration. So a is equal to v into dV by ds. So substituting that value for acceleration in the equation of F is equal to ma, that is here, we will get F is equal to m into v into dV by ds, or F into ds is equal to m into v dV. But we know F into ds is the work done by the resultant force F in displacing the body by a small distance ds. Okay, work done is equal to force into displacement. Here the displacement is ds, it's a very small displacement after the application of force F on a body. Then F into ds is the work done. Okay. So integrating the equation on both sides, we will get integral 0 to s. F into ds equal to integral u to v. The velocity was changed from u to v. That integral into integral m into v into dv. F into ds from this equation. F into ds is equal to m into v into dv. We integrate both sides with putting the appropriate limits. That is, for the left hand side, that is displacement from 0 to s, and for velocity from u to v. If we integrate and simplify, when we simplify, we will get it as f into s is equal to mv square by 2 minus mu square by 2, or f into s is equal to half mv square minus half mu square. Okay, so what is F into S? It is work done. F into S is work done, and this is the change in kinetic energy of the body after t seconds. Okay, so for work done is equal to change in kinetic energy, and this equation is known as principle of work and energy, and it is expressed as or defined as the work done on a body is equal to the change in kinetic energy of the